Here we are at example 1 from our 2.3, number 2 set of notes. We're asked to write the equation of the tangent line and the normal line to this curve at this particular target point, 1, 6, and here is our function. We notice that we have a binomial times another binomial, and there are a couple of ways that we can go ahead and proceed, but for right now, we know that we can go ahead and just distribute, or essentially FOIL, these two binomials together. And so when we do that, when we're expanding this polynomial, we end up then with x squared times x gives us x cubed, plus x squared, plus 2x squared, plus 2x. Now we can go ahead and combine our like terms. So then we end up with the polynomial y is equal to x cubed plus 3x squared plus 2x. Now for a moment, let's go ahead and just focus our attention on the tangent line. Well, if we're trying to figure out what is the tangent line, then that means that we have to have a tangent slope. And from that, we know that we have to then take the derivative to determine what is the tangent slope at a particular target point. So taking the derivative with respect to x on both sides, we end up with y prime is equal to 3x squared plus 6x plus 2. Now we can go ahead and determine what is the tangent slope at a particular target point. In this case, we're looking and throwing at 1 into this function to figure out what is that tangent slope. So y prime of 1 comes out to be 3 times 1 squared plus 6 times 1 plus 2. So then it looks like our tangent slope at 1 comes out to be 3 plus 6 is 9 plus 2, which is then 11. So our tangent slope comes out to be 11. Now we can go ahead and use point slope with our point and our tangent slope to construct that equation of the line. Point slope again is y minus y1 is equal to m times x minus x1. Going ahead and throwing in our items, we have y minus 6 is equal to our tangent slope 11 times x minus our x1, 1. From here, all it is simplifying. We have y minus 6 is equal to 11x minus 11. Adding 6 over, y is equal then to 11x minus 5. So again, this would be our tangent line. Now let's go ahead and focus our attention on a normal line. A normal line is very, very similar to a tangent line, only we're going to go ahead and use our perpendicular slope to this. So essentially, if you had a graph doing something like this, and our target point was happening at 1, 6, we know that we can go ahead and construct the equation that's tangent to this, and where it pretty much just grazes at one point at that one target point. So again, that's a tangent line. A normal line says that we're going to go through that target point and be perpendicular to our tangent line. And as a result, that's why we're going to literally take the perpendicular of our slope. It still has to pass through that target point though. Now in order then to create our normal line, again we have to figure out what is the perpendicular slope. So we have 11, and in order to find the perpendicular, we know that it's comprised of two things. And we've learned this back from algebra. That is the opposite, so negative 11, and reciprocal. So negative 1 over 11. Essentially, you're taking these numbers and flipping them. So as a result, this is actually now the slope that we're going to use for our normal line. Still using point slope, y minus y1 is equal to m times x minus x1. Well, we have our slope, we have our target point. All you need to do is throw them into point slope. So then we have y minus 6 is equal to our change of slope, negative 1 over 11, times x minus 1. And from here, all it is simplifying. So we'll go ahead and distribute this in. So we have y minus 6 is equal to negative 1 over 11x plus 1 over 11. Add that 6 over to both sides. Y is equal to negative 1 over 11x plus, when you add that over, it should be 67 over 11. So this would be our equation of the normal line. Again, though, that is example 1 from our 2.3 number 2 set of notes.